Okay, so this was our estimation for number of conformations of the unfolded protein, 6 raised to the number of residues, and we can rearrange this based on logarithms. Okay, if we have a protein that's 50 amino acids long, we have R times 50 times the natural log of 6. If we want to look at entropy change for the folding reaction as the forward reaction, so we're always doing sort of the final state minus the initial state, so folded minus unfolded. This would be 0 entropy minus the entropy of our unfolded state, and so this was approximately negative 744 joules per Kelvin mole. So this is for 1 mole of these proteins. Okay, this particular imagined 50 amino acid protein. Okay. And so then we already talked about, we expect the sign of delta H for folding up, thinking of proteins only, to be negative because we're going to make more interactions than we had before. Okay, when it's unfolded, the hydrophobic groups can't interact with other hydrophobic groups. They have water that they are not making proper interactions with. They're not making polar interactions or hydrogen bonds with the water. They can't make hydrophobic or van der Waals interactions with other hydrophobic stuff. But once we fold things up, all of the polar stuff can maybe form hydrogen bonds in the backbone, can bond with itself, either in a helix or in a beta sheet. Hydrophobic stuff, especially in the core, is going to be able to be in close proximity to each other. So again, in going from unfolded to folded, we have way more interactions in the folded state, and so we expect this sign to be negative. And it is in our estimation. Okay. So we had some new assumptions for how to think about the delta H term for our 50 amino acid protein. So here was our delta S term. For enthalpy change, we imagined that every single residue could make one favorable interaction, and if I had a mole of that residue, because remember, we're only going to think about, the actual energetic contribution of a single residue making a single interaction is like times 10 to the negative 22nd joules. And it's something really tiny to think about, so we'll think about moles. But let's say everyone makes a favorable interaction that's about 3 kilojoules per mole for that residue. It is negative, okay? So if we have sort of 50 amino acids here, we have our negative 3, we have negative 150 kilojoules per mole. And when we plug that all in, we spit out a positive value for delta G, which didn't make any sense for us because this would be non-spontaneous. Okay? So in this case, when we consider a system that is exclusively proteins, the unfavorable entropy outweighs the enthalpy in this particular case. But we know that this is spontaneous, and what we haven't talked about is water. Okay? And so it's important to remember, have I defined my system as proteins, water, proteins and water together? Which in the body, it's proteins and water together always.